Hello. So I'm doing the check your readiness that we did for our exponentials unit. And what's really important here is keeping track of how we can represent multiplication that happens over and over again compared to addition that happens over and over again. We're going to be studying two basic types of patterns, one pattern that adds the same amount every time or subtracts, and one pattern that multiplies the same amount every time or divides. And so just pay really close attention to how we show those and how we write them different ways. Okay, so number one, this is a false statement right here. 4 to the third actually means that you're repeating the multiplication. If I did 4 plus 4 plus 4, that actually means I did 3 times 4, or equivalently, 4 times 3. So I know that these look very similar because both of them are talking about 3 copies of 4. But when you write the 3 up in the exponent, you're saying 3 multiplications of 4. And when you write 3 times 4 down on the same line, you mean 3 additions of 4. This second one here is true. This third one here is false. The left-hand side is 5 copies of x being multiplied. The right-hand side is 5 copies of x being added together. Okay. D is also false because 3 squared means 2 copies of 3 being multiplied. 2 times 2 times 2 means there were 3 copies of 2. So 2 copies of 3 are different than 3 copies of 2. Okay, part E is tricky because it seems false. The left-hand side is 9 times 9, and the right-hand side is 3 times 3 times 3 times 3. So those are different, right? There's 2 9s versus 4 3s. But if you actually calculate them, this comes out to be the number 81, and this also comes out to be the number 81. So they happen to be the same thing. A way you could have seen that without calculating is if you grab 2 3s here and 2 more 3s here, you can see that this is really a 9 and this is another 9. So both of them have the same thing. Or equivalently, you could split this up into 3 times 3 and another 3 times 3. Okay? Part F is true because we have 4 copies of 1 over b multiplied. That's why there's a power of 4. So you'll hear me say this over and over again, but the power is the number of times the base is multiplied. The power of 4 is the number of times the base, 1 over b, is multiplied. All right, looking down at number 2, 4 times 3 to the x when x is equal to 2 means I'm going 4 times 3 to the 2. PEMDAS, your order of operations, means you do your exponent first. 3 times 3 is 9. 4 times 9 is 36. Please don't make the mistake of trying to do 4 times 3 first to get 12. It's not 12 squared. It's not 12 times 12. It's 4 times 3 squared. The exponent happens first. On number 3, the answer is 1, which is sometimes surprising for people. So I want you to think about this pattern here. If I did 5 to the third power, I'd do 5 times 5 times 5, and that turns out to be 125. If I did 5 to the second power, that's 5 times 5, and that turns out to be 25. And if I did 5 to the first power, that's just a single copy of 5. And what I want you to think about is, how do I go from this to this and from this to this? How do I go from 125 to 25? And how do I go from 25 down to 5? And the answer is you're dividing by 5. And this makes sense because I'm going backwards in my powers. I'm going from 3 down to 2 down to 1. Going forwards in your powers multiplies. So going backwards goes the opposite of multiplying, which is dividing. So follow that pattern one more time. What do you get if you do 5 divided by 5? Well, 5 divided by 5 is 1. Follow the pattern on the left-hand side. 3 goes to 2, 2 goes to 1, 1 goes to And you can see why this is true. 5 to the 0 is equal to 1. By the way, there is nothing special about the number 5 here. I could have done the exact same pattern for the number 7, 2, a million, 7.3, any number to the 0 power equals 1, with only one exception. I want you to think about what number could possibly be the exception to this pattern. Okay, let's go to the next page here. Select all the expressions that are equivalent to 2 to the 10. So remember that this means 10 copies of 2. Well, part A works because that's 9 copies of 2 times one more copy of 2. Part B also works, and the reason part B works is if I look at the numerator, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And if I look at the denominator, I have a single copy of 2. So you might think, oh, but that's 12 2's being written down. Remember, however, that 2 divided by 2 is equal to 1. And if you multiply by 1, it doesn't do anything. So we can just get rid of it. We can cancel out the 1. And the remaining number of 2's is 10. There are 10 2's remaining. So B is also a true statement. C is a false statement because that would be 2 copies of 10. 10 times 10 is way different than 2 times 2 times 2 times 2 times 2. Okay, so no, bad. 10 times 2 is also bad. 10 times 2 would be going 2 plus 2 plus 2 plus 2 plus 2 10 times in a row. All right, part E is 2 to the 5th squared. So that would look like this. 2 to the 5th times 2 to the 5th. And it would look like that because the power of 2 is the number of copies of the base that I write down. I write down the base 2 times. If I expand that out, the first one means the number 2 5 times. 1, 2, 3, 4, 5. And the second one means 1, 2, 3, 4, 5 copies. Altogether, 10 copies of 2. So it turns out to be A, B, and E are all correct there. Okay, almost done here. Number 6, we have some points on a line. What I would suggest doing with this one is let's try to find a missing value, because this table kind of goes out of order. But we know it's a line, and what we know about lines is that they add the same amount every time. And so when I look at my x values, if I go from -2 to 1, -1, I get a +1. With my y values, I get a +3. And so that tells me that I just need to do +3 again. -2 plus 3 is 1. So if I go up 1 in the x, I go +3 in the y. Up 1 in the x, +3 in the y. Up 1 in the x, +3 in the y. And it's really good that I landed on 10 because I was just double checking that I found the right pattern. But the question actually asked us to write an equation. And the equation here shows the two things that I noticed. That I go up 3 every time. And if you look right here in the middle, when x is equal to 0, I need to get an answer of 1. If you double check, any of these xy numbers fits the equation. Meaning, if I look at 2 and 7, for example, 3 times 2 makes 6, plus 1 makes 7. If I look over here, 3 times 3 makes 9, plus 1 makes 10. The y value is always 3 times the x value, plus 1. Okay, just a couple more questions talking about percent. Please remember that the word percent is really two words. Per means out of or divide, and cent means 100. And so if you look at a number like 40%, what you should do is do 40 divided by 100, which is just the same as 0.40. In fact, the word decimal means out of 10, and the word percent means out of 100. And you may have noticed that all I did was move the decimal place 2 times, and that is true because 10 squared is 100. So if you have a percent, move the decimal twice, and you have it equivalent in a decimal. So if your child ate 30 grams and the brother ate 40% more, I multiply by 0.40 and I get 12. Does that mean the brother ate 12 grams of cereal? Let's read it carefully. Child ate 30, brother ate 40% more. How many grams did the brother eat? The brother ate more. The brother ate 40% more. And so I have to do 30 plus 12 equals 42. If you want to do that in one step, you can think of it like this: 30 times 1.40. And the 1.40 is thinking of 140% because they ate 40% more. So they ate 100% plus 40 more percent. Similar idea on part B. We have $30 shoes, price reduced by 25%. So I have a decimal point that gets moved to make it 0.25. That gives me 7.5, 750. That's not the price of the shoes. That's how much they were reduced by. And so if I do 30 minus 750, I get 2250. If you want to do that in one step, you can say 30 times 0.75. And 0.75 comes from thinking if you have a 25% sale, they cost 75% of the original. Okay, last question. 10% more than X. I showed you two ways to do this in those previous problems. We either add 10% to the original price, or we multiply by 110%. Okay? This is adding 10, just 10 as a whole number. That doesn't work. This is adding 10 as a percent, but it doesn't do 10% of X. So this part B is no good. Part C is good. This one here is exactly what I did in this first process right here. I took X and I added 40% of X. This one is not good. This is doing 10% of X and then adding 10. Part E is good because it is adding like terms. 0.1 plus 1 makes 1.1. And same is F. 0.1 plus 1 in the parentheses and then times X. So please let me know if you have any questions, and I am happy to help out. That was a little preview of what we're learning this unit.